final video for the test solutions. If you haven't been having traumatic flashbacks to when you wrote this test, feel free to like and subscribe. Now, if the trauma has been too much for you, feel free to not do that. On to question 4. So, where we start with this one, we've got to write out a balanced neutralization reaction. All right. And okay, so that's the equation. Sodium hydroxide reacting with sulfuric acid, right? Remember, these two guys essentially just trading places. So we end up with sodium sulfate and water. Okay, and then we have to balance it. So we're going to have to put a 2 out front here, 2 out front here, and it should be good. Okay, so what is next? Well, we have to determine normality. So I took the following process. You don't have to take this process. There is a shorter way, but this is just how my brain works. So where we're going to start is we're going to find out how many moles of sodium hydroxide we have. So a couple things to write down about this first. 1 mole is 1 equivalent. Okay. 1 mole is also 23 plus 16 plus 1 to equal 40 grams, right? So this is the sodium, this is the oxygen, this is the hydrogen. So this is the molar mass of sodium hydroxide. So we have 3.5 grams of it. And then if we want to find out how many moles we have, right, we just do our dimensional analysis, and we get 0.0875 moles. So this is our number of moles, sodium hydroxide. This is also our number of, equivalents, right, because we have a 1-to-1 ratio there. So that means we know the normality of this base. It is 0.0875 over 0.288 because we're told in the question that we have 288 milliliters, right? So this gives us, getting ahead of myself, this gives us a normality of 0.30382, and I just decided to carry a lot of decimals just for that part. I'm going to round this for the calculation. The question is asking us what is the normality of this sulfuric acid. So we have NaVA equals NbVb, normality of the acid, right? Same as last time. Normality of the base, we just established that, right? So I'm going to put 0.304 times the volume, 0.288. And this is why I say, you wouldn't have to go in this direction the way I have, because you might notice we're just multiplying these two together. What we just did division to get, right? Remember that NaVA equals the number of equivalents of A, right? So we already know the number of equivalents. So you could have just skipped this whole step. But anyway, if that's confusing, feel free to ignore the last 30 seconds. 0.304 times 0.288 divided by volume of acid, we are told that we have 115 mils of acid. So I've just converted both volumes into liters, and this gives us a normality of 0.761. Okay, and we have answered the question. All right, so that was 4 on to the last question, question 5. So you are given the following. You're told that you have hydrochloric acid reacting with ammonia to produce water, ammonium, and chloride. Sorry, this is not very clear. That's supposed to be a plus, right? It's a polyatomic ion. Okay, so you're given this first reaction, and then you're given a secondary reaction. Now you have ammonium, okay, reacting with the water, and it is producing in a reversible reaction ammonia once again, and hydronium. Okay, so you're given these two and you're asked to explain what in the world is going on. So first thing we need is the names of the reactants and products for each reaction. We need to state whether they are strong acids or bases or conjugates, state what will be true of the final solution, and what process these two reactions are illustrating. Okay. So I broke this down into dealing with the first equation first. So hydrochloric acid reacts with ammonia to produce water and ammonium and a chloride ion. So it is incorrect to call this chlorine. It's a chloride ion. Okay, so that's the first point. Then in this, we can say hydrochloric acid is a strong acid. So the way we labeled this before, we'd put strong acid. Okay. Ammonia, and I'm using symbols now because I've already named them, so I don't need to keep writing out the name every time. Ammonia is a weak base. And this was given to you. This was given to you in the resources page or formula sheet. What else can we say? Well, if hydrochloric acid is a strong acid, that means the chloride ion, which came from this, must be a weak conjugate base. So chloride is a weak conjugate base. Okay, weak conjugate base, and then that makes, well, if ammonia is a weak base, then we have ammonium, which is a strong conjugate acid. And because it is strong, that is what is going to result in it reacting with the water. So for number 2 then, we can say, and again, since I've already named them, I don't have to keep writing the names. Ammonium then reacts with the water, donating a hydrogen ion or a proton to the water, right? Because it's acting as a Bronsted-Lowry acid, so it's donating hydrogen, producing ammonia and hydronium. And I haven't named hydronium yet, so I should write its name. Okay, so there's that. And so now going back to the question, I have answered. I've stated the names of the reactants and products for each reaction. I've stated whether the reactants are strong acids or bases or conjugates where applicable. State what will be true of the final solution. Well, the final solution, right, we have this reaction going on here. This is going to increase the concentration of hydronium ions. So it's going to leave the final solution slightly acidic. And you could have mentioned that the salt is an acidic salt. Okay, so that'll be true. And then last thing, what process are these two reactions illustrating? This is an example of salt hydrolysis. And we're done. Give yourself a check mark.